Students, welcome back to the class. Today I am going to discuss with you very important topic of optics, that is total internal reflection. Okay, so let's start total internal reflection. What is total internal reflection? Let us first draw diagram. See here, this is diagram. This is an interface. ठीक है इसको. This is an interface XY. Here is medium 2 and here is medium 1. This is medium 1. This is medium 2. We consider this is the denser medium. Medium 2 is denser medium and medium 1 is rarer medium. Okay. This is denser medium. Now let's start the explanation of total internal reflection. Here we take courses of rays. I draw here courses of rays. Let us consider an object O. This is an object O placed in denser medium. ठीक है. Consider an object O placed in denser medium. Consider this is water and this is air. Rarer medium is air. First of all, we take this course of ray. This ray incident on the interface. This is the interface which is separating the two media, denser media and rarer media. The interface is XY. Let us take an object O which is in the denser medium and a ray of light from this object O is incident on this interface, and first course of ray we take, that is go straight in the second medium and remains unrefracted. Okay? First ray goes straight in the second medium. Let me take second course of ray. This is second ray. This is second ray incident on the interface, and all of you know that in case of refraction, when ray travel from denser to rarer medium, then it bends away from the normal. Okay, ray bends away from the normal. So it incident on this ray and it bends in this direction. This is angle of incidence and this is R. Okay. Now we take second course of ray. This is second course of ray. This ray incident on this and it also bends away from the normal here in this way. Now we take again third ray. This ray when incident on this interface, and we see here that this ray refracted along the interface. This ray refracted along the interface. Okay, and when this ray incident on this ray, this interface and refracted around the interface, and we see here that this angle, this is the angle of incidence here, and this angle will become when angle of incidence, when a ray this angle of incidence in the denser medium, for which the angle of refraction is 90 degree, for which the angle of refraction is 90 degree in the rarer medium, is called as critical angle. ये जो आएगा, this one, where when the ray takes this path along the interface, grazes along the interface, ray grazes along the interface, then we say that this angle of incidence in the denser medium, for which the angle of refraction is 90 degree in the rarer medium, is called as critical angle. And this angle I is equal to angle IC. IC means critical angle. And this angle of refraction, this will be 90 degree. This will be 90 degree. Clear? When the angle of incidence is further increased, when the angle of incidence is further increased, when the angle of incidence is further increased, the ray is not refracted now. The ray is not refracted now, but it is totally reflected in the denser medium. But it is totally reflected in the denser medium. What I say, when the angle of incidence is further increased, then the ray is not refracted but is totally reflected in the denser medium. And when the ray is reflected in the denser medium, this process is called as total internal reflection. The process is called as total internal reflection. Now what we can say? We can say that total internal reflection is the process in which a ray of light from denser to rarer medium strike the interface at an angle greater than critical angle for that medium that is totally internally reflected back into the denser medium, and the whole process is called as total internal reflection. Clear? And the process is called as total internal reflection. Clear? Now you people can write easily. What will you write? You can write, consider an object in the denser medium, a ray OA. This is OA. This is OA. A ray OA incident on XY bends away from the normal. As the angle of incidence is increased, the angle of refraction goes on increasing. For a certain angle of incidence, the refracted ray becomes parallel to the XY, and the angle of refraction is 90 degree. Angle of refraction is 90 degree, and this angle of incidence in the denser medium, for which the angle of refraction is 90 degree in the rarer medium, is called as critical angle. Clear? And when the angle of incidence is further increased, this angle of incidence is further increased, the ray is not refracted. The ray is not refracted, but it is totally internally reflected. Back in the denser medium. This process is called as total internal reflection. Internal reflection. Thus, we can say that the total internal reflection is the process in which a ray of light from denser to rarer medium strike the interface at an angle greater than critical angle, and the process is called as total internal reflection. Clear? Clear to all of you? Now we take here conditions for total internal reflection. First condition, what is the first condition? Ray of light must travel from denser to rarer medium. First condition is ray of light must travel from denser medium to rarer medium. Ray of light must travel from denser medium to rarer medium. Second is angle of incidence. Angle of incidence should be greater than critical angle. Okay, conditions क्या है? What are the conditions for total internal reflection? First is ray of light must travel from denser to rarer medium. Then we can get total internal reflection. The second condition is angle of incidence must be greater than critical angle. When angle of incidence will be greater than critical angle, then we can get this angle of incidence, and then this is angle of reflection. Angle of incidence, when angle of incidence greater than critical angle, then we can get total internal reflection. Okay, now we will derive relation between refractive index and critical angle. Critical angle. Let's see with the critical angle. ठीक है, for medium 1 and medium 2. ठीक, 2 is the denser medium and first is the rarer medium. ठीक, okay, from Snell's law. Then from Snell's law, you people know that Snell's law is sin I upon sin R. But here sin I, when critical angle, this condition takes relation between refractive and refractive index and critical angle. Then here sin I, what will be sin this I will be I C, or we can say C critical angle, sin C, or we can write here sin IC upon sin R. What is sin R in this case? What is angle of refraction in this case? That is 90 degree. That is 90 degree equal to refractive index of medium 2 with respect to medium 1. We can write this in this way, this relation. What sin 90? What sin 90 is 1. Sin 90 degree is 1. So sin IC upon 1, refractive index of medium 2 with respect to 1, or refractive index of 1 with respect to 2. हम इसको रिवर्स कर सकते हैं. We can take reciprocal of it, that is 1 upon sin IC. This is the relation, or we can write mu is equal to 1 upon sin IC. This is the relation between the refractive index and the critical angle. This is all about today. Thank you.